Is time series data crushing your database performance? InfluxDB handles millions of data points per second with a database built specifically for time series workloads. Thousands of developers have already switched for faster, real-time insights. Ready to see the difference? Visit influxdata.com today.
Hello everybody, I have in front of me Laurent and Geoffroy to discuss about something a bit futuristic if you want, WebAssembly kernels and what are the benefits that this might bring. But before that, Laurent, Geoffroy, can you please introduce yourself?
Sure, I'll start. My name is Laurent Doguin. I'm the Director of Developer Relation at Couchbase. I write stuff about Couchbase, I talk about Couchbase, and I talk to our customers who do fancy stuff with WebAssembly and sometimes serverless, which is why I'm here today.
Hi, I'm Geoffroy Couprie. I'm a Rust engineer at ProtonMail. I'm using WebAssembly daily, and I've been in previous jobs, so it's been a pretty large part of my work for years now.
Thank you. But let's take a step back and start from the conversation that got us here. Laurent, there is some time since we met in London, but still that conversation was quite interesting. And you presented something to do with serverless and WebAssembly. Can you give us the gist of that presentation and how serverless and WebAssembly fit together?
Yes, so I was at QCon in London in April, I think, and I did a presentation about how the new Wasm component model was the fast best friend, fast function as a service. The gist of it is when you're building a serverless platform or a function as a service, it means you're basically running untrusted code. And running untrusted code, we've had different solutions for this in the past. People have been isolating code from a variety of ways. The main reason being you need isolation because process can do weird things to your kernel. Basically, let's say you run two processes on the same machine on the same laptop and one process does something completely stupid, like for instance, rebooting the machine, because why not? It could. Then you've lost everything, right? So you need to isolate those processes. The metaphor I usually use is double dipping, which is also in my talk. There's a scene in Seinfeld, the TV show, where you get someone taking a chip and putting that chip into a guacamole bowl, and then he hit the chips and then he dips the chip again. So he's basically sharing his microbiome, his microbes, or maybe his good bacteria, who knows, with the rest of the people that will use that guacamole bowl. Now, that's perfectly acceptable if you're doing this with people you trust 100%, maybe even 110%. You could do this with your wife. You would probably not do this at a funeral with lots of strangers, which is exactly what happened in that TV show. When you're sharing a kernel with two processes, that's what's happening. You're basically using the kernel as a guacamole dip, and there's a variety of ways to make sure, let's say, to mitigate things that could go wrong. You could start by first running only one process on one machine, and then you could maybe isolate that process by running it into what we call a virtual machine. A virtual machine is an isolation level that's provided by the CPU, by the hardware stack, and it's basically telling you that you're in a fully isolated environment. When we talk about virtual machine, people tend to think about VirtualBox or VMware. People tend to think about very slow thing that takes 30 seconds to boot. We've gone a long way since then. You can run a virtual machine in a very fast and efficient way using KVM, using micro VM frameworks like Firecracker, and I'm sure we're going to talk more about this later. But that was the original way that people used to isolate stuff. And then something showed up. It was called Docker, or Docker was based on LXC. It's not really virtualization. It's called containerization. And the good thing about containerization, it's very easy to use, much easier to use than VMs. The problem with containers, it's not as isolated. You're still sharing the same kernel. There's no hardware security enforced by the CPU instructions. So containers are great, containers are popular, but it's not as safe as VM. And so people started to add more on top of this. They've used things like gvisor, like Kata containers. They try to add more solution to make containers safer. And at the same time, the VM people add more solution to make VM more lightweight and faster. And so that's sort of the runtime solution you have right now when you want to create a safe environment to run code that you don't know. And that's without talking about WebAssembly. And the whole point about this talk was to introduce WebAssembly as a solution for that.
Great. So trying to put everything what you said in a nutshell, the biggest problem as infrastructure provider is that you're running code that other people are putting there. You don't know what you're actually running. So in order not to contaminate it, you need to isolate it. And there are multiple solutions to that. We can look at their history, but WebAssembly is coming now into the frame as a more lightweight, faster to start and stop solution, right?
Yeah, absolutely. It's bytecode that runs on a virtual machine, basically. And that virtual machine gives you access to very few things. It basically gives you access to a memory space that you have no way to get away from that memory space unless it's explicitly been said so by the virtual machine, by the runtime. So it's extremely isolated in theory. The only thing, it's a low list security model. By default, you cannot do anything. And then the runtime must tell you what you're allowed to do and must tell you how you get away from the very, very strict boundaries that you were given at runtime when executing that function or that bytecode.
But does actually serverless exist? Because in the end, there is always a machine behind the scenes, regardless of how we are having it in the infrastructure. And I think that was the use case that you two worked in the past on. And because that sounded more like that, more in terms of infrastructure. So maybe let's look into that a bit more.
Right, because it wasn't just about serverless, it was about functions. We were running a platform as a service company and we were running other people's code. And most of the application code was running into containers or running into VMs, mostly VMs, micro VMs. But we needed to go a little more granular, and that's where Geoffroy came in with the idea of basically re-platforming or creating a function as a service on top of a new technology, which was not a VM, well, not really, but which was much smaller.
Yeah, so the interesting point was at the time, 2018, I went to look at the WebAssembly spec when I started reading about that. The interesting part when looking at that spec is that it was not really meant for the browser. It was a pretty generalist platform. I got the idea that, maybe that could run on the server side. And I went to just hack on that for like 3 days. Maybe I can make some WebAssembly code run on a WebAssembly interpreter and have it like execute a web app, a small web app. And that was running pretty well. The thing that was missing was like a very good isolation. At the time, we were both working at Clever Cloud, French web hosting company. Virtual machines were in the DNA of the company. Everything was on virtual machines. I got the idea after having messed with hypervisors a few years back that maybe I could just load the WebAssembly generated code, like taken from the bytecode and compiled to machine code, and run that directly in a virtual machine without even an operating system. Because since the WebAssembly runtime has to expose exactly what the app needs, and there are no other dependencies, then maybe I can specify exactly what the virtual machine exposes, and we don't have to expose any kind of weird hardware or anything, just exactly the API we would need. And that's where the idea came from.
That makes sense. So what were you targeting? What were mainly the problem? Everything was from the perspective of the security, or it was more also in terms of optimizing the usage and making it maybe more profitable?
There was security, like for the virtual machine part, but also performance. What people are always looking for in serverless platforms is how to run the cheapest way, small piece of a web app, even cutting up an app in various elements that will run concurrently. So maybe this endpoint is called a lot and we need to provision some machines, but this one is only called once a month. So maybe it's on the scale 2.0 application. That's the kind of play people like to do with serverless. And so the idea was that, can we make the cheapest way to run code safely in WebAssembly? That was a pretty huge bet. A few things needed to be done. Like, how can you make a virtual machine boot extremely fast? Even faster than how most containers boot. There were a lot of tricks to get that. But I don't know at which point, how fast they are starting now at Clever Cloud, because the project still hasn't shipped. But I was pretty close to 1 millisecond at the time to boot a virtual machine and have running code inside.
That's impressive. Where did you get started? What was the initial time of booting the machine to just get the factor of the improvement?
That was like taking virtual machine and taking it down to the smallest elements. So a virtual machine is basically a virtual CPU. You ask the KVM API in Linux, make me a virtual CPU. You provide some buffers and say, here's your RAM. That's where you have your memory. And this part is executable. This part is not. This part is writable. This part is not. Like you decide exactly what you want. And from there, you just decide that you do not make any hardware. Like you don't need a network card. You don't need basically anything. You just need a way to communicate with the host. And for that, I used IO ports, which was like the simplest way to communicate. I could have made a kind of VirtIO device in the same way that most distributions can make Linux that works on VMs right now. Like now, if you want to run Ubuntu or something on the server in a virtual machine, the hypervisor is not emulating any real hardware. It just provides a VirtIO device, and the guest knows that it's running on an hypervisor. And so it's just say, I want to send something on a network over there, and is not talking to a real network card. But even that was not needed, just like the simplest way to load code. And from there, it's about booting the virtual CPU. So a fun fact is that even for virtual CPU, you have to do the boot sequence like you do with a normal CPU, where it starts in 16 bits mode. And then you have to make a few instructions to make it move to 32 bits and then to 64 bits. It's like you start in the 80s and then you have to progressively go into the future, feature by feature.
So it's back to the future whenever you're booting the machine, right?
Yeah. You have to do all of that like very, very quickly. But once you have the vCPU and the RAM and you have loaded whatever you wanted in the buffers, then it's there. So you don't have a boot sequence for the entire OS at this point because you don't have an OS. You can just point to the part of the buffer where you put the code and say, hey, execute from there. That's it. The vCPU will just start executing.
So if I understand correctly, by the end of your optimization journey, let's call it like that, you got to booting in 1 millisecond, right?
Mm-hmm.
What was the initial time in which the machine booted? Okay, well, the virtual machine booted.
I think at first it was like 20, 30 milliseconds.
Okay, wow, that's impressive. It's 30x improvement. Yeah, kudos to that. And what did you use at that point? Laurent was mentioning earlier Firecracker, or maybe you can single out a couple of the tools that you came across at that point.
Yeah. So at that point, it was pretty early. So if you wanted some good Rust bindings to the KVM API, you had to go, and there was a small library you could fork from the Chrome OS open source code. And I started from there. I did a few patches. And a while after, some people started the Cloud VMM project in exactly the same way, starting from this small library. And I think Firecracker ended up using Cloud VMM too. So Firecracker is this hypervisor that's made by Amazon, I think. And its entire design is to boot a Linux virtual machine faster and in a very safe way. And so it's using basically the same tools.
So this was like probably the early days of this movement, let's call it. How are things now?
Now, I'd say there's a lot of existing actors. You may have seen some projects around like Crustlets, which were some WebAssembly machines that would run in the Kubernetes cluster. There's been Fermion, that's an entire company around that. Microsoft is also doing with the Hyperlight project basically the same thing, compiling WebAssembly code to native code, running that on very light virtual machines. So yeah, they're making pretty good progress there as well. So I guess the pattern is coming into mind. Like before we had the idea, if you want to sandbox something, you need to use all of the tools that Docker is using. But now virtual machines are becoming very easily accessible and hackable. So people are looking into what they can do with that.
Yeah, but I think also last year, I saw a lot of content during the QCon about how they are marrying Kubernetes with WebAssembly to get more speed. I had the earlier discussion, I think around April or May this year, with one of the guys that put together the connectors for WebAssembly and Kubernetes. And what he was saying is that for him, the frustrating part is the fact that you have a pod that starts in, let's say seconds. And then you have WebAssembly that is starting in milliseconds. And then it's pointless because you have to wait for the pod itself. But I think there is a lot of stride moving in this direction.
Yeah, that's kind of what sparkled my talk about Wasm at QCon. I've been working with the folks at CNCS Wasm Cloud, and basically they're trying to have the same sort of API that Kubernetes have, but instead of pods, they're managing WebAssembly binaries. And so they're basically telling you to recompile, rewrite your application to Wasm directly so that you don't have that overhead that you would have using traditional Kubernetes. You could have a compatible API, but manage Wasm binaries.
That makes sense, especially that a lot of the more efficient languages these days have a target to compile into Wasm. So that will make things a lot easier, especially that you don't have an intermediary step. From the compiler itself, you can just wrap it and have it out the door. But looking at the ecosystem, what do you think it will make things even better? We are talking futuristic. So what do you think it's still needed to make it even greater than what we currently have?
So an issue we have when a language compiling to WebAssembly is that a lot of the languages and libraries in the languages have some assumptions on the system under it. Like, oh, I have a POSIX like a network API. Or even I have network, I have files. And reconciling that between Windows and Mac and Linux, or even like a web or desktop, is pretty hard to do. And with WebAssembly, it's an entirely new platform where you need to provide some of that. And so even if you can compile the code, like just raw code that is not doing any side effects on the network or files to WebAssembly, that can work. But then once you start using normal libraries that anybody in that language would use, suddenly you can get where, but I cannot just write to a file there, and that's actually blocking me from using this pretty well-known library. That's one of the main issues, and that's what they're trying to fix with stuff like Wasm, which is specification for an interface between the WebAssembly application and the host to provide common APIs like that.
To just see if I got it correctly, what you said is that currently, in the end, we still have to run on some kind of machine. And currently, there are multiple types of interfaces. To just break it down in 3 different categories like web, Linux, and Windows probably. You need to harmonize these interfaces so it's easier to just go from one platform to another. Would that sum it up?
It's more that WebAssembly is another platform. Like a lot of languages already support Windows, Mac, Linux, but they now have to support WebAssembly. And it's not just about compiling, it's about making sure that a lot of libraries will be able to use Wasm effectively, or their standard libraries.
Because the main issue is still that you have to convince people that Wasm is a good platform to build stuff. And we come from a time where you had to manipulate bytes directly. You had some shared memory. You take those bytes and then you try to figure out what to do with those bytes. They can be a float. They could represent a string. You don't really know what it is. And so this has been standardized very recently, the Wasm component model. And it sort of gives you a common understanding of how to serialize data across and function calls across WebAssembly binaries. So that's a good step towards adoption. People are working on this. And then, of course, there's the WebAssembly system interface with Wasm, which is standardizing how you would use host functions, which is what Geoffroy was referring to, making sure that we have a common interface that can be implemented by everyone.
Okay. Just to make sure that it's clear for our listeners, we have WebAssembly that pretty much provides, let's call it a container, even though it's more than that. And then we have the Wasm, which is the WebAssembly system interface that provides mechanism through which WebAssembly can safely call different parts of the hardware of the host system. Am I correct?
Yeah.
Okay, great. Where is Wasm at this point? Last time when they were in 0.1 and they were looking at 0.2, did they evolve from that point on? I didn't follow it lately.
I haven't been following that much either. What's interesting is that the WebAssembly standards are made by the Bytecode Alliance. And the Bytecode Alliance has very different key players into it. Most of them are clouds, actually. Most of them are selling hardware. And you did mention something we haven't answered yet, which was about pricing. When we did the function as a service at Clever Cloud and pricing, it was really, really hard to price because, frankly, it is extremely cheap and it is in very few interest as a cloud platform to sell something that cheap. And I don't know if that's a reason, but the Bytecode Alliance has been fairly slow, and Amazon's in the Bytecode Alliance, and a bunch of clouds are in the Bytecode Alliance. And yeah, it should drive costs down quite a bit for everyone. So, is this the reason why it's going slow? I don't know. It's just an observation.
Yeah, well, it's a tendency to frugality after you had a long period of time during which everybody was just adding cloud services and adding. Now it's in the reverse trend, but I think it's a fair point to add that if things will just be cheaper, probably to just churn some of the profits, right?
Yeah, cheaper and greener as well, because of course less machines.
Yeah, this kind of gets hand in hand, and I think that's one of the interesting benefits of the green tech movement, where it's cheaper on the CO2 side, but also on the pocket in terms of finance. Okay, so the Bytecode Alliance is the one calling the shots, but Is there somebody that has more weight into that? As you said, AWS is part of it. Who are the other big players into the Bytecode Alliance?
One of the biggest was initially Mozilla, but Mozilla is getting smaller right now. And there's been a lot of help from Microsoft, from Amazon, Fastly. Fastly got deep into WebAssembly early. Fermion, FutureWay. There's a lot of actors.
Intel, Shopify, StackBits. It's interesting because they all have various interests. Some will be very, very at the bottom of the stack, would be about providing infrastructure, and some will be at the top of the stack, like Shopify. It's just providing plugins to their infrastructures, or StackBits, things like this. And Nginx as well.
Yeah, it's quite an interesting. I was just scrolling through the list of companies that are part of the Bytecode Alliance, and it's
a wide group.
Pretty much as you said.
And it's very different interests.
Exactly. So if you look at it, it's very heterogeneous. You have Amazon, ARM, and then you have Stellar, the blockchain, cryptocurrency, but also Mozilla and Nginx. So interesting sum up of people. Excellent. Thank you, guys. A last question from me. Is WebAssembly a silver bullet? Because if you look at it, it started from the browser. Now we're talking about infrastructure. But also, I spoke to people that were just trying to put a box in a box, meaning that they were trying to put WebAssembly in the JVM. So what do you think? Is it a silver bullet? Where are its limits?
The JVM analogy is interesting because the JVM has sort of the same fate than WebAssembly. It started out to be something specific and ended up being something completely different. It ended up going away from the initial use case. Now you can use it on the server, but also, you had the applets, you had embedded Java, you had all sorts of things that were not necessarily the way it was first conceived for. And I think WebAssembly is following the same trend. And people say Java is dead, but Java, is still alive. So that probably means that Wasm has a good future ahead of it. Is it a silver bullet? Yeah, probably.
Yep, I think so too.
I've been at Wasm.io in March with 150 people that were all excited about the future of Wasm, and it was probably all sort of convinced that it is a silver bullet and it's going to be the future. So personally, I'm very excited about it.
Fair point. Thank you.
Yeah, you cannot do everything in Wasm, and it's still a pretty limited platform, but the limit is what makes it useful. You want to write your entire application in WebAssembly, maybe that's not the right call, because if you want to have like a huge microservice, like a huge thing to run, then write it in your language and use the container or something. But if you have a small thing that you don't trust particularly, or that you want some kind of behavior, some little piece of code to go from one place to another in your infrastructure, WebAssembly is pretty good fit for that. Like, you can have a very small piece of code, that it does not need a lot of requirements from the host, and you can predefine those. And you can run that in about any kind of process, and it will not disturb whether you have Java, Ruby, C++. Like, you can have your WebAssembly runtime in the same process, and it will run the code pretty isolated. So that's a good fit for like very small isolated tasks.
It's interesting because you say that, because it's not as mature in terms of ecosystem, so you might want to use your usual ecosystem. But will there be a day where it's going to be as mature so that it becomes counterproductive? Because you also said like the value of this is not a very big ecosystem, it's very small, it's precise, it's secured. So like the more open it becomes, the less useful it becomes.
Yeah, but at this point, we'll have another new technology that will come up that will replace WebAssembly.
Fair.
Okay. Thank you for your time. Anything else to add on your side, guys?
No, it was great to be here, and I'm hoping people will get interested into Wasm.
Well, there is plenty of interest, so let's keep it going. Geoffroy, anything on your side?
Nothing for me. Thank you. I was happy to chat.
Thank you as well.